I have Hans Alfven here. I went ahead and printed this off of the Plasma Universe Wikipedia like encyclopedia. Here's the front page of it. That's what it looks like. The introduction, as it has stated here, introduction, says, in 1937, Alfven argued that if plasma pervaded the universe, it could then carry electric currents capable of generating a galactic magnetic field. After winning the Nobel Prize, I would say he actually earned that damn thing. Winning that doesn't do it any justice. He earned the Nobel Prize. For his works in magnetohydrodynamics, he emphasized that, quote, in order to understand the phenomena in a certain plasma region, it is necessary to map not only the magnetic, but also the electric field and electric currents. Space is filled with a network of currents which transfer energy and momentum over large or very large distances. The currents often pinch to filamentary or surface currents. The latter are more likely to give space, as also interstellar and intergalactic space, a cellular structure. Now, that, in essence, I think is one of the big reasons why a lot of the people, his peers, didn't give him a lot of respect for his work, because they disagreed with the idea of electrical interaction happening over very, very large distances, because electromagnetic force is powerful at the close distance. When it's a long distance, it's gravitational interactions that play the leading role. Now, I know a lot of EU people are claiming that, oh yes, electric currents and all that are the most important in terms of interstellar and intergalactic space. But I'm here to kind of point people in a different direction. Alfven knew what he was talking about, clearly. But the reason why he wanted to adopt the idea of transferring energy and momentum over very large distances is because he was trying to solve the angular momentum problem of the protoplanetary disk model. So in essence, the wrong theory, the false protoplanetary disk theory, led him to make the conclusion that somehow the angular momentum had to have a mechanism for transfer. You can't just condense balls of rock and gas that are spinning around another object in the center without making it lose its angular momentum. You have to get that material to slow down and collapse into a ball. So what mechanism could slow those spinning objects down? Well, he proposed that the charge of the interstellar environment could do that. That the objects, when they were spinning, could transfer angular momentum using electrical interactions with outer space. But what he did not see is the discovery I made. Obviously, he has passed away a few years ago. I think it says here, April 2nd, 1995 is when he passed away. I would have loved to tell him that applying MHD to very large scales, such as losing the angular momentum of the planets when they're forming around the star, was unnecessary. What happened was that they had the false philosophy that the objects all formed at the same time, that they're all the same age, and that they formed from a disk. So he was trying to use false philosophy. His ideas were great, but he was using the false philosophy of all his peers and assuming that all the objects formed in a disk and they had to have lost angular momentum somehow. So that's why he went in that direction. Where he should have gone in the direction of is the stars themselves are the areas where electrical fields play a large part, the magnetic fields play a large part, and the electric currents are important, as well as the currents when they pinch and filament, and there are surface currents. Those all apply to the star structure itself as it evolves. And its angular momentum, yes, can be lost via coronal mass ejections, solar flaring, and radiative loss. because when the star cools, it radiates all that stuff out of it and it shrinks, and the angular momentum is lost. So yes, charged particles are coming out of the sun, which are removing the angular momentum from the sun. So it's naturally rotating, but when it loses all that charged material, that mass flies away. That's where the angular momentum is going, and it's slowly cooling and contracting, keeping the same rotational velocity as it does so. In other words, the star will cool and become the planet, and all the other objects that are around the sun are very, very different ages and stages of their evolution. And we can apply MHD to their actual internal structure as they evolve. Meaning, the stars, they pinch all over the place in their surfaces. They have surface currents, and they even make filamentary structures on the surface. We can see them with the telescopes that we have in outer space that are watching the sun. The observatories out in outer space, we can see all that stuff happening. But I just wanted to point that out. The reason why he was aiming more towards the direction of trying to place filamentary structures across interstellar distances. I'm not too sure if that was the approach that he should have taken, because it alienated him. He should have only looked at the large distances inside of a star itself. The sun is 100 times the diameter of the Earth. The effects that the sun experiences are very large distances. So to say even larger distances, you need to have actual plasma there. It doesn't quite work when it's in vacuum. The interactions that we see in MHD are magnetohydrodynamics, meaning there's actual material there. So to try to apply MHD to interstellar space is the same problem a lot of astrophysicists are facing with the problem of forming molecules in the vacuum without activation energy. As well, it's the same problem as the planet formation, where they have planets being formed outside a body. So you have this right here, I don't know if you can see it. Okay, all of their processes you have outside a body. You have planet formation chemistry over here in the vacuum, up here in the vacuum, up here in the vacuum. And the star, some surrealistic fusion reactor, and then the planet somehow forms from some surrealistic protoplanetary disk. And the correction is just to simply place the chemistry, the MHD, and the planet formation inside of the star itself. That's how you solve this solution. A lot of the ideas that they have are being forcibly pushed into a corner, if you will, because it's the fusion nuclear people that dominate the sun studies, and they'll be damned if somebody comes in there and tells them that the sun is actually electromagnetically influenced, that it's powered by MHD processes, that electrochemistry plays the leading role for why it's hot, and that planet formation itself is the process of star evolution. But that's the root philosophy. They have everything outside a body when it should be placed in the star itself as it cools and dies. So, in other words, Alfven was making the same mistake as his peers in placing a lot of the processes that were happening outside a body. And when clearly they happen inside the magnetosphere, even Birkeland currents that happen inside of magnetospheres, which are inside an area where there's already charged particles. It doesn't happen in a vacuum where there's nothing, there's no magnetic fields, there's no pressure. So it's a basic change in philosophy that we're heading towards, and hopefully people can understand why even people like Alfven were a bit misguided in a way. He was following a false theory that's been plaguing the astrophysical community for over 300 years. and it just simply won't go away. We have to literally replace that theory with a more reasonable understanding. Today is August 13th, 2015. Hopefully this video helps people.